In the last section, we took a look at how we're going to write from MATLAB to be able to write to a text file or an Excel file. In this section, we're going to take it a step further, and we're going to go ahead and start learning how we can create files for graphs. All right, and this one's actually a pretty easy process. Let's say you have some sort of graph, whether it be a scatter plot or a functional graph or even a subplot sort of graph. What you could do is you can just go ahead and plot whatever it is, and then use this print function. All right, now the print function we can use, and print is going to have two parameters. The first parameter is the file name, so whatever you decided to call it, and then what type of file, in other words, what type of graphic file that you're choosing to create. So it could be a PNG, it could be a TIFF file, or it could be a JPEG. Just depends on your preference. I always use a JPEG, all right, because they're pretty universal. So are PNGs. I don't use a lot of TIFF files, but you might find that it's necessary in some instances. If you want to read data in, first of all, you have to know whether it's a text or an Excel file. If it's a text file, you're going to use the same command, file ID fopen. You're going to name the file that you're opening. Right? And this should have apostrophe there, but you're going to have, instead of W, you're going to have R. So that means it's a read only. Then what you're going to do is you're going to define what type of data that you're reading in. Is it character? Is it decimal? Is it floating point? Is it integer? Whatever it might be. I always use %f if it's numerical, just because you can't go wrong with it. You can always format it later. And then finally, if you want to assign it to a column vector, in this case, we're going to call it A. We're going to use the function fscanf, and that's going to read the text file. File ID is assigned to whatever the name is. And then the format spec is the different type of data that you're looking at. With an Excel file, instead of XLS write, we're going to use XLS read, and we're just going to read in from the file. And what this is going to do is it's going to store everything in a single variable, which means that we probably want to put columns into each. We want to try to assign a different variable for each of the columns. All right. So, for instance, we can use this command, a:1. And what this means is anything in column 1 is going to be assigned to variable 1. Anything in column 2 is going to be variable 2. Anything in column 3, variable 3, etc. All right, so that's probably the easiest way to work with an Excel file. If we have numerical data, we probably wish to use statistical commands. And here's some of the statistical commands in Excel, pretty easy ones: max, min, median, mode, and range, standard deviation, that sort of stuff. Okay, so given all of that information, let's go ahead and start to be able to work with some larger scale sort of problem. You might have to break this up into 2 videos because it is a fairly large problem. But let's say for some reason, somebody has a whole bunch of data in some sort of text file. So in the example I'm going to use, I pulled the average temperatures in all the days in January 2020 for Newcastle, Delaware. And first, we're going to read the data. We're going to convert it to both Celsius and Kelvin because it's initially in Jan temps, and we're going to store it in Jan temps F, Jan temps C, Jan temps K. And then we're going to create a row vector of integers 1 through 30 and create a scatter plot of the Jan temps to the day in January. All right, and we're going to label it. Once we do that, we're going to print everything that we've computed into an Excel file. All right, so this is kind of a new thing that we're going to do. We've already done all the things before where we've done conversions and we've done scatter plots. And then we're also going to print everything, all the statistical data that we know how to do, into sheet 2 of the same Excel file. All right, so the raw data we're going to put in sheet 1. Some of the summary data we're going to put in sheet 2. All right, so let's get to it. First thing we need this file data1. All right, and it might be one of those things, well, how do you get it in there? Okay, so what I usually do, let me delete this so that way you can see how we're going to work this. So I'm going to delete this file, right click, delete. All right, so now data1's gone. And I'm just going to go in here, and in my computer, I just open up my folder that I have. And what I'm going to do is I'm just going to copy and paste. So I'm going to copy this animal, and I'm going to go over here, and I'm just going to paste it. All right, and right here, now data1 is now in the folder. All right, so just do it from the main MATLAB screen. All right, now first thing we have to do, we're asked to be able to read the data into a file, okay, to read the data and store it into jantemps F. So what we're going to have to do is we're going to have to use file ID, and we're going to have to fopen. And we're going to fopen our text, which is data1. And the attribute that we're going to use is a read-only file. All right, so right now this is our file ID and it's open. And now we want to go ahead and store it. So we're going to do a scan. So we're going to do jan temp f is going to be equal to, we're going to go ahead and do an f scan f. And we're going to say file ID. So now we're scanning data1.txt. And then we're going to tell it what data type. I'm going to say %f. All right. Now let's stop there and just let's go ahead and open this and let's close it out really quickly. So let's do an F close so that way we don't get stuck. All right. And I'm just going to show you what's going on with this. I'm going to suppress it and I'm going to run. And I have to name it correctly. That would be helpful. You guys probably noticed that. All right. Now notice everything is in a single column vector. Okay, so all the data now is in MATLAB. So we read it from the text file, it's in MATLAB. Now I'm going to suppress this. I'm going to suppress this, the F close. Now the F close is going to be the very last command that we use. Next thing we're going to do is we're going to convert to Celsius. All right, so we're going to have jan temp C. And remember the formula, 5/9 times, and remember we use dot times because it's a vector, 32 minus F. So now this is a column vector. And we're going to do the same thing for jan temp K. And that's going to be, remember the formula for Kelvin is we're going to take whatever's in jan temp C, and we're going to add 273.15, I believe. All right? And we're going to suppress that. So right now we have 3 column vectors. Right? If we look at our instructions tell us to convert to Celsius, convert to Kelvin. We already have the data stored. So now we have these 3 variables, which are column vectors. Now we're going to create a row vector. And we're going to go ahead from there. And we're going to construct the scatter plot. All right, so let's give that a shot. So we're going to construct a row vector I. So I is going to be equal to 1:1:31. So that says that all the numbers 1 from 31 are now in I. And we're going to plot I, jan temp F. All right, now let's see what happens with this. And let's go ahead, it's a scatter plot. So I'm going to use, let's use diamonds because we can. And I'm going to go ahead and run this. And jan temp F. So it's saying F is not recognized. So unrecognizable function of variable F. So let's see. And that's in line 7. Oh, right here, that should be jan temp. Okay, let's try again. All right, now we have a scatter plot. That's good. Doesn't look like there's any patterns. Looks like a 5-year-old grabbed a marker and started scattering the paper. That's just because in January there's some really high days and some really low temperature days. All right, so far so good. Now the data also says, or the instructions say that we have to print this out to a scatter plot or print the scatter plot to a file. And we're going to call the file ftemps JPEG. All right, so we're going to print. Remember our command is print. And we're going to print whatever our file name is. All right, so let's call that ftemps, okay, or whatever you want to call it. And it's going to be a JPEG. So we're going to say -DJPEG. All right, now this is going to be pretty cool if it works. And right here is our ftemps. Okay, so that's our JPEG. Now I'm going to open it, and I always open outside of MATLAB, and it might take a second for it to open, but there we go. So now we have a file that we can open. All right. Now I need to go ahead and give it the appropriate labels. So I'm going to say X label, and that's our days in January. So the day in January And our Y label is our temperature in Fahrenheit. And then finally, our title is going to be temperature for days in January, Newcastle, Delaware, 2020. All right, so let's run it one more time. All right, and down here, it's actually generating the picture. And notice right here, now we have all the titles, we have all the good stuff on the axes. So now we have a legit scatter plot. All right, looks good. All right, next thing. Instructions are to now, so now we've printed out a scatter plot, we have a file. Now we're going to go ahead and construct an Excel file. All right, so this is new. We haven't constructed an Excel file yet. We're going to have 4 headers, and then we're going to go ahead and print out a column of the integers, a column of the temperatures, a column of the Celsius, and a column of the Kelvin temperatures. All right, so we have to be careful when we do this because we have to make sure that when we write it to Excel, we write it to the correct initial cell. All right, so let's do this. We're going to have XLS write. All right, and first of all, we got to name our file. So I can't remember if we have to name it something specific. So Jan 2020 XLS. So let's just call it Jan 2020.xls. Right? Now, I is a row vector. But remember, we have the command I prime. And remember, prime is the transpose. So it's just going to make it a column vector. We're going to print it into sheet 1. And we're going to start this in A2. All right, because we need a header. Right? And I'll get to the header in a moment. Right? Now, all I'm going to do is just do this 4 more times, except instead of I, we're going to have Jan temp F, Jan temp C, Jan temp K. And instead of A2, we're going to have B2, C2, D2. All right, and that gives us some room for our headers. All right, so let's go ahead and run it. All right, so, and we're keeping an eye over here for our file. Unless we made it, oh, there's our file. We don't need this. All right, now I'm going to open this up. I'm going to open it outside of MATLAB because it does take forever if you try to open it in MATLAB. All right, and check this out. We have all the data in sheet 1, and this is our day, our Fahrenheit, our Celsius, and our Kelvin. So now we just need headers for this. So let me close this out. I'm going to create a variable called header. And header is going to be equal to, and we're going to say the day. And I'm just going to call it the F temp, and then the C temp, and then let's call it the K temp. And I'm going to XLS write this header to A1. All right, I'm going to suppress this. And technically, I could suppress all of this. Now, the suppression, by the way, only suppresses it to the screen. All right, so we're not going to see it down here, but we are going to be able to see everything in the Excel file, unless I made a syntax error. All right, so let's run it. All right, so there's this guy again. And there, I was worried because it wasn't showing up with the proper labels. All right, I'm going to open this animal up. And I always close out Excel each time. So it has the day, but the other ones are missing. And I'm not sure where they are. So it should have printed this across. I'm not sure where those guys are. So unless I need a semicolon between those. But I think I did that correctly. So let's go ahead and try a semicolon, although I'm almost certain that it's going to be I'm just making sure I didn't misspell anything. Oh, I see. There was a prime there for some reason. All right, let's try it again. The syntax was correct, so nothing wrong with that. Let's get rid of that. And then as soon as the double arrows come up down here, let's open again outside of MATLAB. Sorry about that. I didn't realize that I had an accidental prime up there. There we go. All right. So what it did, and I didn't even notice it, was it wrote it in a column form instead of a horizontal form. All right. So one last thing, almost done with this. So the last part of the problem, so we've got all the temperatures in Excel file. That's great. Last part of the problem is in sheet 2, we're going to write all of these different statistical components. All right, so we need the max, the min, the mean, the median, mode, range, and standard deviation. So 1, 2, 3, 4, 5, 6, 7. So first thing I'm going to do is I'm going to make a header. So I'm just going to copy this guy right here. Actually, let me copy the header. I'm going to copy this. All right, I'm going to call this header 2 because it's going to go in sheet 2. And remember, our variables are max, min. We have mean, median, mode. And then we have our mode. And then we're going to have our range, I believe. And then finally, the last thing we're going to have is we are going to have our standard deviation. All right. And now, what we're going to do is we're going to write into that. Okay. So this is our header, and we're just going to change the sheet. So it's header 2 and it's sheet 2. All right. So now we're taking whatever's in header 2 and writing it to sheet 2, still A1. All right. Now we're going to do some computations. All right. So first thing we're going to do is we're going to find the maximum. So we're going to have the max of, remember we want the Fahrenheit data. So it's going to be the maximum of Jan, temp, F. Right. So remember, that's our statistical formula. We're going to get it to sheet 2, and let's print it in A2. Right. So that's going to be below the max. All right. Now we're going to copy and paste this 7 times. Right. And I'm just going to, oh, for some reason it executed. That's fine. And I'm just going to change all of these. So it's not really that tough. It's just more tedious once you know the algorithm. All right, so that's our 7 outputs. And then finally, we're going to change this to min. We're going to change this to mean. We're going to change this to median. We'll change this to mode. Now, over here, we need max minus min to be able to find the range. And this is our Jan, temp, F. All right. And then finally, our standard deviation, STD. All right. And here's our fclose file. So almost done. And hopefully I didn't make any syntax errors. All right, so let's give it a go. Let's see what happens. Now I'm going to delete this. So I'm going to delete this animal because we don't need it. I'm going to delete this animal. So basically, we're just running it like it never existed. All right, so I'm going to run. And hopefully I didn't make any spelling errors. All right, so it gives us a warning. That's fine. No big deal. It just tells us it added something. So let's open this animal up and see what happens. All right, so in sheet 1, here's all of our data. All right, so all the 3 different temperatures, and here's sheet 2, and here's the maximum, the minimum, the mean, the median, the mode, the range, and the standard deviation. Very cool. If we wanted a histogram of this, we could go ahead and get a histogram. In fact, let me just show you that just because we can. So I'm just going to say histogram of our Jan temp F. All right, and that's just going to print out a histogram. It's going to print it to the screen, not to a file, but just to show you what Excel can do with the histogram. Probably pretty cool. It might take a moment to actually get anything out. And here's our histogram. And we can clearly see, I didn't put any labels on it, but there's a lot of days in January 2020 between 30 degrees and 50 degrees. And you might remember that last year in January 2020, we had an unusually warm winter. All right, so this is pretty cool. Somebody that's an environmental engineer might go through and try to study these patterns or something like that. So pretty cool that now we can use all this with MATLAB. So hopefully this helped you to see everything that we can do so far with MATLAB. There's one more example that I'm going to show in a subsequent video. It's a little more scientific than this one. This is just a pretty elementary example. So if you want to see a little bit more advanced example using trajectories, you could take a look at that.